This video goes with the 6-2 guided notes for trapezoids and isosceles trapezoids. So we define a trapezoid as a quadrilateral four-sided figure with exactly one pair of parallel sides. We call those parallel sides the base, and these other sides we call the legs. In an isosceles trapezoid, we have a pair of congruent legs. So we have one pair of parallel sides, and then the other two legs, or the two sides, are congruent. We call those the legs. In an isosceles trapezoid, the diagonals are congruent to each other. Also, the base angles are congruent. These green angles at the top would be base angles. If this was upside down, this would be the base. If it's right side up, this is the base. So we call these base angles. This side we call the base, this side we call the base. We call this the leg, and we call this the leg. So base, base, leg, leg. In an isosceles trapezoid, the two legs are congruent, which sets up these congruent diagonals. Otherwise, it's obvious in this trapezoid here, this normal trapezoid, these diagonals are not congruent to each other. So they're not congruent. In isosceles trapezoid, they are congruent. Okay, so if a trapezoid is isosceles, then each pair of legs and base angles, they might be looking for base angles, are congruent. So I reworded that a little bit. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. ISOSCELES. A trapezoid is isosceles if and only if its legs are congruent. Okay, let's move on. Is each trapezoid isosceles? Justify your answer. So base angles congruent gives us isosceles trapezoid. Legs congruent gives us isosceles trapezoid. Let's see what we got. If this is 55, together these need to make 180. We have parallel lines cut by transversal. Same side interior angles are supplementary. This is going to be 125 degrees. That gives us the 180. This angle here now is going to be 65 degrees. We do not have congruent base angles, so it's not isosceles. Here we have congruent diagonals in this one set of parallel sides. This is isosceles because it has the congruent diagonals. The midsegment of a trapezoid is the average of the two bases. It's exactly halfway in between. So the midsegment of a trapezoid is a segment that connects the midpoints of the legs of the trapezoid. So this piece and this piece are congruent. There's the midpoint. This piece and this piece are congruent. There's the midpoint. So mid-segment connects the two midpoints of the legs. It's going to be half the length of the sum of the two bases. So it's parallel to the bases, and it is half the sum of the bases. half the sum of the bases. So you add the two bases up, divide by 2, you got the mid-segment. It's actually like the average of the bases. Let's move on. Okay, so number 3, UR is the mid-segment. So it's going to be the average of these two. So if we add 11 plus 18 and divide by 2, that's going to be the length of UR. So 29 over 2, which is 14 and a half, is the length of UR. Here, this is the mid-segment. We want to find the length of it. 34 plus 19 divided by 2 is going to be the length of JF. This gives us 53 over 2, which gives us 26 and a half for the length of JF. So we got 26 and a half. Over here we had 14 and a half. Let's look at number 5. RN is the mid-segment. We want to find the missing one. Now this kind of plays off on the same formula. This is half both of these. So since this is half of both of these, I could actually say 16.7 plus x is equal to 24 times 2, 48. So 16.7 plus x is equal to 48. And take 16.7 away from both sides. X is going to be 31.3. If we check it out, 31.3 plus 16.7 adds up to 48. Divide 48 by 2, we get the 24. Same thing here. This 22 is going to be equal to half the sum of these. So let me use a more traditional formula. 14.4 plus x divided by 2 equals 22. So the average of the bases is equal to the mid-segment length. Get rid of the 2 in the denominator. 14.4 plus x equals 44. Take away 14.4 from both sides. We get 29.6. So this must be 29.6. Over here, this must be 31.3. Let's talk about kites. The kites is a convex quadrilateral with exactly two distinct pairs, two pairs of consecutive congruent sides. They call them adjacent. I would call them consecutive. Its diagonals are perpendicular. Exactly one pair of opposite angles are congruent, and we call these the vertex angles. No, we call these the non-vertex angles. The non-vertex angles are congruent. And these vertex angles, the A and C angles, then are going to be bisected by the diagonal. Let's look at this. So altogether, these angles need to add up to 360 since it's a quadrilateral. And angle N and angle L are going to be congruent to each other. So if I call these X, altogether these need to make 360. We have two X's plus 123 is equal to 360. Two X's is equal to 360. Take away 123, which is going to be 247, 237. And X is going to be 237 divided by 2. It's going to be 168.5. So angle N and angle L measure 168.5. Okay, number 8, ABCD is a kite. So kite has non-vertex angles congruent. So right away, we know this has to be 107. And altogether, these need to make 360. So the two non-vertex angles give us 214. The other angle at C is 90. That gives us 304. Altogether, they need to make 360. That leaves angle A 56 degrees. That's what they're looking for number 8. For number 9, find the values. Now, in a kite, remember the major diagonal, the long diagonal, bisects the minor diagonal and is the perpendicular bisector of that minor diagonal, which makes these right angles. So, and also the sides are congruent. So to find AB, we're basically stuck using Pythagorean theorem. Since this is a right triangle, we have a squared plus b squared is equal to c squared. 144 plus 36, take the square root of that, that's going to be the length of AB. So AB is going to be the square root of 12 squared plus 6 squared, which is 144 plus 36, which is the square root of 180. Now the square root of 180, let's see, what could we do with that? That's 18 times 10, 9 times 20, it's 36 times 5. So if we look at 180 as being 36 times 5, we've got the square root of that. That's going to give us 6 times the square root of 5 in simplest radical form. Now if we needed a decimal for square root of 180, we're looking at like 13 times 13 is 169, 14 times 14 is 176, 15 times 15 is 220 or 196. So it's between 13 and 14 as a decimal. But exact numbers, 6 radical 5. 6 times the square root of 5 is the length of AB. Now the length of CD, same thing. Now we got a 12 and a 24. So we got 12 squared plus 24 squared. Take the square root of that, and that's going to be our length CD. 12 squared is 144. 24 squared is, I think, 476. 576, 616, 620. Looks like square root of 620 is CD. Now, don't quote me on that, but that's what I think it is. And it wants to know the perimeter. Basically, we're going to have 6 square root of 5, another 6 square root of 5. 24 times 24. Just 24, 24. 16 carry 1, 8, 9, 8. Yeah, 5. Oh, it's 576. 16 carry 1, 8, 4. It's 576. It's 576, 676, 720. So we got square root of 720. That's a little bit better number. Now square root of 720. 720 is 36 times 20, and we're taking the square root of that, and 20 is 4 times 5, so we've got 36 times 4 times 5. The square root of 36 is 6, the square root of 4 is 2, and we're left with square root of 5, so 12 square root of 5 is the length of each one of these in terms of square roots, 12 root 5 and 12 root 5. So altogether the perimeter is 12 root 5, 24 root 5, 36 times the square root of 5. Now you could do this in terms of decimals, but this is the exact answer rather than the decimal answer. Let's look at number 10. We want to find WX. So here we have a 8 and a 6. Now an 8 and a 6, that's like an 8 and a 6. That's like a 3, 4, 5. It is doubled. So this would, if this was a 3, 4, 5 Pythagorean triple, or if this was a 3, 4 Pythagorean triple, that would have to be a 5. Since this is double the 3 and double the 4, this length must be 10. So we can use Pythagorean triples without having to worry about doing square root of 100 on that one. And over here, 8 and 24, this is another Pythagorean triple. Let's see what we got here. This is 576 again. And 8 squared, 576. And 64. 0, carry with the 1, 8, 14 gives us 640. So this is square root of 640. Square root of 640. Okay, that's 64 times 10. That's the best we could do. 64 times 10, which simplifies to 8 square root of 10. This is 8 square root of 10 and 8 square root of 10. So in terms of, okay, so Wx is 10. Zy is 8 square root of 10. Now the perimeter is going to be 20 plus 16 square root of 10. That's going to be our perimeter. In exact numbers, if you want a decimal approximation, you could have done the square root of 24 squared plus 8 squared, and you could have got the decimal, which would be the approximation of 8 square root of 10.